Alright guys, so let's get into our first practice problem for Pythagorean theorem. Alright, so in our triangle, let's identify the parts first, alright? Which part is our hypotenuse? That would be part C, because it's the part directly across the right angle, right? And so what do we need to do to solve for this missing side of the triangle? We need to use the Pythagorean theorem. Pythagorean theorem lets us solve for any side of the triangle that's missing, okay? But remember, it's only for right triangles, okay? So, Pythagorean theorem formula is a squared plus b squared is equal to c squared, okay? So let's pick which one's a and which one's b, okay? It doesn't matter which leg is a or b, okay? The only thing that really matters is for you to identify the hypotenuse, okay? The hypotenuse will always be c, okay? And we know that the hypotenuse in this case is c right here, okay? So we're going to make our a 8 and our b 6. And like I said, it doesn't matter. It could go the other way. We can make our a 6 and our b 8, alright? So let's plug them in. A squared plus b squared is equal to c squared. In the case of our problem, a is going to be equal to 8. B is going to be equal to 6 squared. And when I say squared, I mean to the power of 2, okay? And that's going to equal c squared. Now what's 8 squared? That's 8 times 8. And that would be 64. And then add that to 6 times 6, which is 6 squared. 6 times 6 is 36. And now let's get to c squared. So what's 64 plus 36? 100, right? So now we know that 100 is equal to c squared. Alright? Now, let me erase this, and then we'll get started on the next part of this. So now that we know that 100 is equal to c squared, how do we get rid of the exponent right here? The opposite of an exponent is square root, right? Remember we talked about that? So we want to take the square root of this whole part so we can get rid of the exponent in c. We just want basic c. We don't want c squared. We want basic by itself c. So we take the square root of 100 and take the square root of c squared, okay? Now, what's the square root of 100? Now, think about that. This 2 kind of gives you a reminder. You need to think of a number that when you multiply it by itself 2 times is going to give you 100. Any idea what that'd be? 10. Why is it 10? Because 10 to the second power is 10 times 10, and that's 100, okay? So if you take the square root of 100, it's going to give you 10, okay? 10, and you can check because 10 multiplied by 10 multiplied 2 times is equal to 100. Square root of 100 is equal to 10, alright? So the square root gets rid of our exponent in c, and now we know 10 is equal to c. And that's it. We just did the Pythagorean theorem, and we just solved for this side of the triangle. Okay? Let's move on to another problem. Alright, so assume side B and C is 14 inches. So here's B to C, and it's 14 inches. And side B to D is 7. Alright, so B to D, which is right here, that's 7. And side A to B is 12 inches. Alright, so find the length of all the other sides, all right? So let's take a little minute to figure out what we do and what we don't have, okay? So we know that B to C is 14 and B to D is 7. B to D is actually half of the length of 14, which is B to C. So if B to D is half, what would D to C be? The other half, right? It'd be 7. Because 7 plus 7, that's 14. Okay? So we know D to C, and we know B to D. We know A to B is 12, but can we say A to C is 12? Well, let's figure out the other sides of the triangle first, okay? We can't assume A to C is 12, okay? It may look right in the picture, but sometimes pictures aren't to scale, okay? So we can't assume that A to C is 12. So let's figure out the triangle first, okay? Let's figure out this part of the triangle, alright? Let's figure out the side, and get a better color. A, B, and D, okay? Here's the right angle. And now we know that 12 is A to B and 7 is B to D. Okay? But we don't know this side. Let's call that X. Alright? We don't know the side from A to D. We don't know what that is, and so we're going to set that to X. Okay? So if side A to D is X, and B to D is 7, and A to B is 12, what do we use? Pythagorean theorem, right? So let's do it. Let me give myself some room, and then we can write this. So, A squared plus B squared equals C squared. Alright? So, we know in our triangle, B to D is 7. Okay, before we start doing some Pythagorean theorem, let's identify what our parts of the triangle are, okay? So, what's the part across from the triangle, okay? Or from that right angle? That would be our A to B, which is 12. And this side, which is across from the right angle, is also our hypotenuse. And the hypotenuse goes right here, okay? It goes where C is supposed to be. Alright, so it would be A squared plus B squared is equal to 12 squared. Okay? Now, we need to figure out what our A's and B's are. Okay? So let's say B to D, which is 7, we're going to make that our A. So we make 7 squared plus B squared equals 12 squared. Okay? But we don't have the other side, our other side being X. This is the A to D side, remember? This is the part we set to equal to X. So we're going to actually set it equal to B, so that way it's not that confusing, okay? So we're going to leave it as B squared. Instead of using X, we're going to use B, okay? So sorry for the confusion. But let's figure it out, okay? So 7 squared plus B squared equals 12 squared, alright? Let's figure out the problem. But let me just give myself more room because I'm really good. And I'm actually going to redraw the triangle too. That looks cleaner. Alright? So we know B to D, that was 7. A to B, 12. And we're figuring out this side of the triangle, okay? Oh, let me erase that again. Which is our B, our little b, okay? Little b, 12, 7, okay? So let me rewrite the equation. 7 squared plus b squared equals 12 squared. Okay? So we're looking for b. Okay? So what's 7 squared? 7 times 7, right? 49. 7 times 7. Plus b squared is equal to 12 times 12 is 144. Cool? Alright. Now, we need to figure out what b squared is, but we're going to have to use some algebra this time. It's not as easy as the other problem, okay? So, we want to use some algebra so that way we can leave b squared by itself in this equation. So b squared, actually before I get there, how are we going to leave b squared by itself? We need to get rid of this 49, right? If we subtract this 49, we'll get rid of the 49 here, and we'll subtract it from 144 here, okay? So b squared is equal to 144 minus 49. Now, how much would that be? Just do it here real quick. 5, 0, 13, 95. Okay, 1, 240. Yep, 144. B squared equals 95. Okay. So when you subtract 144 from 49, you end up with b squared equals 95. Okay. So I'm just gonna erase real quick and give ourselves some more room. All right. So b squared is equal to 95. All right. So b squared is not equal to 95. Now, what do we do at this point? Square root b squared, so we can get rid of the exponent, right? We want to get rid of the exponent, so we're going to do the square root of b squared is equal to the square root of 95. Okay? So the square root of b squared and the square root of 95 is equal to what? Well, at this point, you're going to want to get out a calculator because the square root of 95 doesn't really go well. Okay? There are some numbers that we call perfect squares in math, like 25, 36, and 100. Okay? Why are these called perfect squares? Because there are numbers, whole numbers, that can get these square roots perfectly. Alright? So, what's the square root of 100? 10. What's the square root of 36? 6. And what's the square root of 25? 5. Because these numbers are literally just a number multiplied by itself. 25 is 5 times 5, 36 is 6 times 6, and 100 is 10 times 10. Alright? But no number multiplied by itself is 95. Think of 8 times 8, 64. 9 times 9, 81. But 10 times 10 is 100. So what about 95? What's the square root of 95? At that point, you're going to need to get out a calculator. So, I'm going to get out mine. And let's figure this out. So the square root of 95 is 9.7. Okay? So, b is equal to 9.7. Okay? So, if we know b is equal to 9.7 now, let's look at our triangle. We know b to d is 7, a to b is 12, and we now know a to d is equal to 9.7. So, if this side is also 7 and this side, and these two triangles share this whole side, now we know that a to c is for sure 12. Okay? It's going to be 9.7, 7, hypotenuse is going to be 12, alright? And so there we go. We just figured out the length of all the sides and we found the hypotenuse. So let's move on to another problem, like problem number 6. So here's your real world life scenario with Pythagorean theorem. A tree makes a 6.2 meter long shadow. Okay? So a 6.2 meter long shadow, and here's the length of that shadow. And the distance from the tip of the tree to the tip of the shadow is 7.5 meters. So the tip of the tree to the tip of the shadow, 7.5 meters. Calculate the approximate height of that tree. Now we need to figure out what's the height of this tree. Now, these trees and this shadow, what shape do you see that it's making? A triangle, right? So let's make this into a triangle. Okay? And we're going to assume that this is the right angle. Okay? And so we're going to also compare the measurements here and put it in our triangle. Okay? So 6.2 is going to go right here. 7.5 is going to go here. And what's this side? The height of the tree. That's what we're going to figure out. So we're going to call that one x. Alright? So before we just start doing Pythagorean theorem, what do? Let's identify the parts of the triangle. So do we have the hypotenuse? Yes, we do. Because the hypotenuse is the side across from the right angle, which is right here. Do we have A and B? Yes. We have A, which is 6.2. Sorry about that. We have A, which is 6.2, but we don't have B, which is our x. Okay? So let's get rid of the x like we did with the last problem, and we're just going to call this part B. Okay? So again, we're looking for B. So let's rewrite this. A squared plus B squared equals C squared. 6.2 squared plus B squared equals 7.5 squared. Okay? Now, what do? We're going to multiply 6.2 by itself twice, right? Now, if you don't know what 6.2 times 6.2 is, off the top of your head, I recommend using your calculator for that one. So 6.2 times 6.2 is going to be 38.44. Okay? Remember, 2. Okay? 6.2 times 6.2 because we have the 2 exponent, alright? So we have 38.44 plus b squared, and what's 7.5 squared? So what's 7.5 times 7.5? If you do it on your calculator, you should get 56.25. Alright? So if we have 38.44 plus b squared is equal to 56.25, how do we solve? Well, let's get some room for ourselves because we're going to need it for this problem, okay? I like the problem super hard, but we're just going to need room to write. So what's 56.25 minus 38.44? That is going to be equal to 1 here. 5 times 28.8, 4 here, 1 here, 15, 7, 17.81. Just going to double check on the calculator. 17.81, alright? So, how do we get rid of 38.44 so that way we get b squared by itself and eventually just b? We subtract 38.44. Sorry for the bad handwriting. And you'll end up with b squared is equal to 17.81. Now, again, you're going to need a calculator for this part, okay? Take the square root of b squared. Now, on your calculator, depending on what you should do, it should look like this button, okay? The button will look like this. So you type in your number first into your calculator, okay? After you type in the number, then hit this square root symbol. Okay? Alright. So you have the square root of 17.81. You should get 4.22. Alright? So B, which is the height of the tree, is 4.22. But 4.22 what? Meters, right? So B is equal to 4.22. The height of the tree is 4.22 meters. Okay? Now, so let's go over what we did. We identified what we were missing. We put a squared plus b squared equals c squared, which is 6.2 squared plus b squared equals 7.5 squared. Multiplied that out. And then we subtracted 38.44 from this side. And then we were left with b squared is equal to 17.81. We took the square root of both sides, so we get rid of this b squared exponent. And then we're left with b is equal to 4.22. Remember, you got to use your calculator for this one, okay? So let's move on to the next problem. Practice problem 4. So assume that in the rectangle, side AB is 8 inches. AB, 8 inches. And side AE is 6 inches. Okay? Find the length of side BE, which is this side. Now, does the triangles within the square, do they have right angles? Yes, they do. You don't want to know why? Because the corners in each square are all right angles. Okay? So, we have a right triangle with A to B being 8 and A to E being 6. Now we want the length of B to E. Okay? So, what are we going to do? Pythagorean theorem, right? So let's identify our parts of the triangle first, alright? So we're going to make 8 part A, 6 part B, and what's the hypotenuse? The side across from the right angle, which would be right here, which we're missing, so we're going to call that C. Okay? So A squared plus B squared equals C squared. 8 squared plus 6 squared is equal to C squared. Now this is going to be just like the last problem we did, where we multiply 8 by itself, so we're going to get 64, plus 6 by itself, which is 36, and that's going to give you C squared, so 100 equals C squared. What do we do to get C squared, to get rid of the exponent on C squared? We take the square root. So let me erase this. So 100 equals C squared. Take the square root. Square roots will get rid of this exponent in C. And what's the square root of 100? 10. That's equal to C. Perfect. So we found the length of side BE, which is 10. Oops. Now how are we going to find the BC and CE? Do you want to do Pythagorean theorem for all those? Nah. Because you know the properties of a rectangle. Because you know that rectangles are made of two sides that are congruent. So if B to A is 8, and the opposite side to C to E is congruent to B to A, congruent meaning equal, then B to A should be the same as C to E. So C to E should also be 8. B and C and A and E are congruent, so A to E should be the same as B to C, and B to C is also 6. Now we found all the sides. Alright. Let's get into our last problem. So this problem is kind of intense, okay? I'm not saying that to scare you, but I just want you to know that you're going to have to think a little bit more for this problem, okay? Because this problem is really two problems in one, okay? So we have two triangles. because one triangle within a bigger triangle, okay? So how we should start with this problem is solve for the smallest triangle first, and then we'll work on solving for the bigger triangle after we solve for all the parts in the smaller triangle, okay? So if we know that a to b is 12 and b to d is 6, what's a to d? This is the triangle we're focusing on, the smaller one, okay? Where it's b, a, and d, okay? And we know that b to a is 12 and b to d is 16. We want to know a to d, alright? And we'll assume this is the right angle, alright? And do we have a hypotenuse? Yes, we do. Our hypotenuse is 16 because that's the side across from the right angle. So if we wrote our Pythagorean theorem, this is going to be a squared plus b squared equals c squared, okay? So before we get any more further than this, guys, I would highly recommend you guys, if you're not getting these problems, I would highly recommend for you guys to go over your teacher's notes one more time, look through these past videos, and then come back and do this problem with me. I'm not going to be too explanatory about this problem because it's such a long problem and I want to get through this problem as efficiently as possible, okay? So, now that we know that we have a hypotenuse and we have a leg, we're going to assign this leg to be B, okay? And we're going to say that this leg is A and this leg is our C, okay? So A squared, that's 12 squared, plus B squared is equal to our 16 squared, okay? So let's solve that. 12 squared is 144 plus b squared is 16 squared is actually, let me put that in the calculator, 256. How do we get rid of, how do we make b squared by itself? Get rid of 144 by subtracting it, okay? Subtract 144 from 256. b squared is equal to 112. Alright? Now b squared is 112. What do? We take the square root of b squared. Square root of b of 112. Remember to get your calculator for that one because that's not a perfect square. I'm going to round it up to 10.6. Cool, guys? Alright. So b is equal to 10.6. Alright? Point. So now we know what AD is equal to. 10.6. But we're still missing this side. X. Alright? So before we get any further, what should I do? Erase. Equal to 10.6, alright? Now how do we solve for DC? Alright? How would we solve for D to C? Now, let's solve. Now, we know D to C is within this bigger triangle, so that's what we're going to solve now, alright? We're going to solve the bigger triangle, which has sides 12, 19, and half of this, or a big part of it, is 10.6. We still need the leftover, which is X, okay? Now, we don't need the 16 anymore, okay? So forget about that part, alright? We just need to find this remainder, okay? So when we do our Pythagorean theorem, let's assign our sides first, okay? So 19 is going to be our C, because it's our hypotenuse, which is across from the right angle. 12 is going to be our A. Alright. Now that we know what A and C is, what's going to be our B? Now, let me get a different color real quick. And you'll see why. B is actually going to be two parts. It's going to be 10.6 plus our x. It's going to be 10.6 plus whatever is left over, okay? Now, when I write a squared plus b squared equals c squared, I'm not going to write it as a squared plus 10.6 plus x equals c squared, alright? I'm going to leave it in b form, okay? You'll see what I mean right now. So I'm going to write this again up here so we remember. Alright, and then let me erase this. So our a squared plus b squared equals c squared, is 12 squared plus b squared is equal to 19 squared. Alright? Now, what's our b? Our b is this, but we're not going to sub in this whole part right now. I'll tell you guys when. Alright? Now, 12 squared is what? 144 plus b squared. And what's 19 squared? Let me use my calculator because that's a lot to do in my head. 361. Alright? 19 times 19, 361. 12 times 12 is 144. So how do we get rid of 144? You subtract it. And so 361 minus 144, and then 144 minus 144. And that'll make our b squared by itself, okay? So b squared is equal to 361 minus 144, which is 217. Okay? Square root time, right? So b squared equals 217. How do you get rid of the square root? Or how do you get rid of the exponent? Take the square root 217, and b is equal to square root of 217, which is, I'm going to round it to 14.7, okay? So, pretend I didn't do this yet. So b is equal to 14.7. Now we're going to substitute our b for 10.6. So 10.6 plus x is equal to 14.7. Alright? Just so you have a reference for what I did. Now how do we get x by itself? Subtract 10.6. Subtract 10.6. I wrote that wrong. Erase that. 14.7 minus 10.6, and x is equal to 4.1. Now, we have this x. And now we know what the whole side a to c is equal to, 4.1, right? Which is this part. Alright? So, how do we check? How do we check that AC is equal to, actually no, AC is not equal to 4.1. Sorry. I didn't catch myself. DC is equal to 4.1. And now we know that A to D is 10.6, D to C is 4.1, and now we add that up. So if we add that up, what would it be? Well, let's do that right now. So if A to D is 10.6, and D to C is 4.1, what's going to be our A to C? It's going to be 14.7. Alright? So now we know, I'm going to write it here on the top, that AC, I'm going to erase this, AC is equal to 14.7. Alright? Now that we know AC is 14.7, let's check ourselves, okay? we know that the side of this whole big triangle, or actually let's redraw that triangle, now that we know what our missing parts are, okay? We know A to B. So this is our big triangle. This is the big piece that we're solving for, alright? A, B, and C, alright? We know A to B is 12, B to C is 19, and A to C, oh, I wrote that wrong. This is B, and this is A. We know A to C is 14.7. So let's do Pythagorean theorem and make sure it all works out. So A squared plus B squared is C squared, so 12 squared plus 14.7 squared is equal to 19 squared. And if you plug that all in a calculator, you get 144 plus 14.7 raised to the second, 216, let's say 217. Let's round it up to 217. 19 squared, that would be 361. 277 plus 144. Oh, sorry, wrote that one. 144 plus 217 is 361. So we got it right. A to C is 14.7. So, like we said, Pythagorean theorem allows us to find all sides of a right triangle, and it only works on right triangles, and the only pieces of information you need is the hypotenuse and the legs. Okay? Alright guys, I think we've done enough Pythagorean theorem concept and practice for one day. If you guys still need help, here are the links to all my slides and to where I got the information if you guys still want more help. I recommend checking out these websites, and maybe they can give you a different point of view on Pythagorean theorem if you still need help, okay? So, looking forward to hearing from you guys and seeing what type of math topics you still need help with. Really fun Pythagorean theorem stuff we did today. It's just a mouthful of a word. And thanks for sticking around. So remember, as always, math is beautiful.